Have this thing called the MIDAS process, which is how you build a solid gold pipeline that is going to stick around for a long time, that people understand, that people know how to debug. That people know how to improve, and it really allows pipelines to have a lot longer long-term value. And in this 2-hour course, we're going to be going over everything that Airbnb does to build these pipelines. I'm really excited for you to check out this course. And if you want to build more pipelines in the cloud, definitely check out the dataexpert.io Academy. You can get 20% off. off in the description below.
How many of you have experienced working with bad data? I think that this is probably one of the things that is a very common pain point with data workers is getting clean data and getting data like able to be good and everything. So what are we covering today? One is how to build high trust in the data sets that you build. Because without that trust, without that acknowledgement and that trust, like, are you really being data driven? If decisions aren't being made off of the data sets that you're creating, are you even having the impact that you're expecting to have? Like, who knows? I think that's a big thing that you want to think about as you're kind of going through this process today, is really think about trust and how trust can be built and how trust can be broken, because both sides matter here, and we're going to be covering kind of both sides as well in this presentation today. Also, how to build good data documentation. The entire lab today is on how to build a spec, and that's also what y'all's homework is this week, is going to be how can you build a good data spec. That is very important. And a lot of times, like, if you actually go through the entire spec process, you will find that you create way better data that answers way better questions than if you just immediately start writing SQL. Like, you're gonna have a way better time if you actually do this upfront thing. And besides that, like, it will increase the quality of your pipeline, but then your pipeline is documented. Then people, non-technical people or other technical people, like other engineers or anyone else who needs to like look at your pipeline and look at the data, they can learn about everything that you're creating way quicker than being like, oh yeah, here's my Airflow pipeline, go read a bunch of Python code and, you know, scratch your eyes out, like freaking, because a lot of times that's currently what most data engineers do. They just like immediately go into Airflow and SQL, and they don't even think about the spec, because there's a lot of pressure to like create pipelines and to give data. There's that, you know, there's that trope of like, you have the data scientist who's like, hey, can you just quickly pull this data for me? And then, you know, data engineers like jump out the window, or they like throw a chair or whatever, right? Because that pressure is just obnoxious. And the last thing we're going to talk about is data quality checks. So, you know, in the first 2 weeks, we talked a lot about facts. We talked a lot about dimensions. Those are great. Data quality checks are also going to be a big part of this. We're going to go into a lot more detail on data quality checks and automated data quality checks next class on Wednesday. But today we're going to go into a lot more detail, especially on like the more theoretical side about data quality checks. So yeah, let's get into this lecture. Okay, so what does data quality even mean? That was one of the things I alluded to in the last couple slides. So one of the most important things for data quality, and it's underrated, but also difficult, is discoverability. So what that means is like, if someone's trying to make a decision and they want to know like, oh, does this data exist? It's easy to get that data. And easy to find that data if it exists. And so like a part of this is like a cataloging problem of like showing all the data that your company has, which is like, that's not as much of a data engineering problem as more of like a data infrastructure problem, but they are related. They are definitely related, and we're going to go a lot more deep into discoverability in a couple slides. You also have misunderstood and incomplete definitions of data quality. So, like, I just want to give a quick example. So I don't know if y'all like remember Zillow. and they thought that they had this like perfect machine learning model that was going to like predict the housing market and predict everything that was going to happen. And then they bought a bunch of real estate, and then they lost like $100 million or something like that. They lost some weird sum of money because they were like so confident in the data that they were creating. But the thing is that their data wasn't high quality enough because they didn't think about the gaps of like, oh, what other things could this model be missing? Like, what other data points might be very important to also include? And sometimes you get, sometimes even if you have complete data, you get other things, right? Like, if y'all ever heard of like black swan events, which is just like a crazy event that happens that is very hard to predict. Like, a good example there is like the COVID-19 pandemic, like being able to predict like when that was going to happen. That kind of black swan event is an example of some things that are like a little bit trickier for machine learning models and data to predict. Sometimes they can get a decent idea, but when they're like rare events, like good luck. So obviously then the third bullet point here is like kind of the standard one of like, okay, for columns that are supposed to not be null, they're never null, and especially for dimension tables, there's no duplicates. So that's great. Let's talk about the last three here. These are trickier. So there is business value being derived from the data. This is one that can be tricky sometimes, because what does that mean? So obviously then the third bullet point here is like kind of the standard one of like, okay, for columns that are supposed to not be null, they're never null, and especially for dimension tables, there's no duplicates. So obviously then the third bullet point here is like kind of the standard one of like, okay, for columns that are supposed to not be null, they're never null. And especially for dimension tables, there's no duplicates. So that's great. Let's talk about the last three here. These are trickier. So there is business value being derived from the data. This is one that can be tricky sometimes, because what does that mean? What does business value mean? So usually that means money in some regard. Sometimes it might be a couple degrees removed from money. Like, for example, say you're looking at, say you're building a pipeline that measures user growth. Say, like, we'll just use Facebook since I work there. So if someone signs up for Facebook, like, how much money does Facebook get when someone signs up for Facebook? They get nothing, right? And so, like, actually tracking how many people sign up, they don't get money directly. That's like a growth, like signups is a leading indicator of money, because it's like the only way that they actually make money is if people sign up and then they stay and they stay in the feed and then they start consuming ads. Because if they start consuming ads, that's when you're going to get a lot more money, right? And some things can be even further removed, right? So think about it this way. Like if, for Facebook, say they went and spent money on Google, and they spent money on Google ads to get more people to go to Facebook. Because then it's like, okay, just because they clicked on the Google ad doesn't mean they're going to sign up. And just because they signed up doesn't mean that they're going to watch stuff in the feed. So that like the number of clicks from Google is even further removed from actually making money. But my whole point here is, generally speaking, like every single data pipeline that you write is either going to generate more money. There's going to be some way that it generates more money, or like has like an obvious way that it is connected to revenue, or it could be on the other side. It could be cost savings, where like you might be making a pipeline that measures how much spend is happening on AWS, so that you quit giving Jeff Bezos billions of dollars. That's one of our goals as data engineers, is to make Jeff Bezos less rich. So that's the idea. Business value usually is revenue. There is one exception here I want to talk about with business value, is if you're creating data sets that provide strategic value. So say you're creating some big data set that is used for some big executive decision, and then it's just to inform that decision, and that might not be money in like a clear, direct path like the other data pipelines that you write are. But those pipelines are also kind of rare. I think I've written like one or two of those in my whole career. So generally speaking, the pipelines that you write are very closely linked to either revenue or cost. Okay, well, what about these last two? Data is easy to use. So this is an interesting one, because I spent the last 2 weeks teaching y'all how to make data a little bit harder to use by using arrays and structs and complex data types, and showing analysts like, hey, you should, use cross-join unnest, or, kind of blow up the data, or freaking like analyze it with these array functions. And like, you're going to have to be a little bit more technical to look at this data, right? And so obviously this is something that is a continuum, and it depends on your data consumer on like whether the data is easy to use or not. But generally speaking, what I mean by data is easy to use is the column names are obvious. The column names make sense. The column names are clearly distinguished. Like a very common thing that happens at Airbnb is you have dimension columns and metric columns, and the dimension columns start with dim and the metric columns start with M underscore. And that is a very common naming convention. I would hope that naming convention gets more adopted like across industry, but some people are different. They like to use other things, and some people are like, oh, that's like excessive. Just put dim in the table name and then you're good to go. Like there's a lot of debate on like the way to actually name your columns. We're going to cover that in another slide. And the last thing here is the data arrives in a timely manner. Like a big common thing between analytics and data engineering is when there's a data delay. Analytics is like, data engineering, like, where's the data? What's going on? And so especially this back and forth happens a lot when there isn't an agreed upon refresh interval. So, for example, when I worked at Airbnb, I worked on unit economics. And when I first was working there, the unit economics pipeline was like so bogged down and slow. And like the refresh interval was 3 days. And so like the only time what it meant was like if analytics came to me and they're like, hey, the data's 2 days late, for me, the response for that is do nothing, right? Just wait. And then if it's more than 3 days late, that's when I'll actually troubleshoot. So coming up with agreed upon arrival times for data is a very powerful thing that can help your analytics teams kind of be more streamlined. And it makes it so data engineers get less requests as well, because then the analytics team can be like, oh, it's delayed, but it's not delayed enough that I need to like ask someone about it. It's like not quite at it's not problematic yet. So those are a lot of the pieces of like what data quality means. There, like obviously there's more to it than that, but that's kind of the idea. So data quality, like in a very short way to think about it, is data trust plus data impact. So it's you have people that believe in the data and believe that it's correct. And then on the other side, you have the data is correct and changing the business. And if you have those two properties of your data sets, you're going to have a good time. That's like, if you can consistently create data sets that have those two properties, you're going to get promoted very quickly. That's like it's more difficult to do than you would think. And that's one of the reasons why we're here in this lab today, is to talk about how to do this, because this is not an easy process to consistently deliver high quality data every time. So yeah, let's dig a little bit deeper into this. How do you build high trust in data sets? So this is coming from the angle of before it's in production, before you've created any pipeline. You really want to lean into empathy is a big thing. I think it's one of those things that data engineers, like generally speaking, don't do enough of. In this case, what I mean by that is you need to get all of your downstream stakeholders together and be like, I love these conversations. They're like some of my favorite conversations, is like you get your downstream stakeholders together and you're like, if cost and time wasn't an objection, what data would you want? And like really have them like shoot for the sky for two reasons. One is it gives you a lot more clarity on like all the problems that they're trying to solve and being able to get more bigger picture kind of things. And it can also give you ideas of like what to do in a year or what to do in 6 months. And as you progress in your career in data, you're going to be wanting to think about those things, especially like if you want to go from senior to staff data engineer, your goal is to determine what to work on next. That is like one of the most important things. So this exercise in empathy can be very important in determining not just what to work on today, but to what to work on in 3 months, in 6 months, in a year, and like really starting to build those like long-term roadmaps of like, what does data excellence look like? So yeah, those conversations are great. Also a spec, and this spec should be reviewed. The spec should be reviewed by a couple people. One is the spec should be reviewed by another data expert. Like at Airbnb, how it worked was every spec that was created had to be reviewed by at least another staff data engineer. So that was a requirement. And so if I wrote a spec, I couldn't review my own spec. I'd have to have another staff engineer review my spec. And so then that was just like a hard requirement. But you also needed the spec to be reviewed by the stakeholders. So both the like a technical review by an experienced engineer and a review by the downstream stakeholders to make sure that you're covering most of the requirements. So obviously that's great. Another big important piece of this is to clarify the business impact, because I think that that's one of the things that people can kind of get caught up with a little bit, is like, how do you have the right amount of business impact and the right way of kind of describing that stuff. And one of the things that's really good is if you can clarify the business impact, that's also something that is great for performance reviews, because sometimes, like, depending on where you're at in the development cycle, you're not gonna, like, say you're doing a spec review and it's December and you're just starting the spec review, then you're not gonna get credit for if you think that you only get credit when you finish a pipeline. That's not true. If you can build a spec that looks very promising, that has a lot of really good business impact, and you can convey all of that within the year and say it's in like November, December, then that can count towards that year's performance review. And that can be a great way to also kind of squeeze in one last thing to get more value into your promotion packet, so that you get most of the credit for that pipeline for the previous year, not the coming year. And that can be another great way to help you get promoted. So like, that's a great thing to think about, and why clarifying the business impact is powerful, because like, you essentially can take credit for the impact before it's delivered. And that is like, I don't know, like I've found that to be so tasty and so satisfying in my career that I've just been like, thank you. I'm glad I found this and saw this. And because then it's like, then you just have to implement it, and then you still get credit on the other side as well. So, also another big thing here is like talking to your downstream stakeholders about current and future needs. So a lot of times, stakeholders are going to have like a burning question. Like, they're like, I need to know availability of Airbnbs in Brazil in July 2023 because there's a big event going on, and da-da-da-da-da-da-da-da, right? It's like they have a very specific, narrow question that they're trying to answer right now. And don't build your pipelines to answer that narrow question. If you do, you're going to have a bad time, because then they're going to come back to you and ask another narrow question, and you're going to build another pipeline that's almost the same pipeline. And then you're like, that's called me and my manager back at Netflix, we called that like bespoke hell, because like you just keep essentially you build a pipeline for every question that analytics has, which is like not the way to go, because you want to be thinking about what their current and future needs are, so that you can build a data model that answers their questions today and the questions they have in 6 months, so that then you don't have to make another pipeline. You can just be like, yeah, the data's already there. And when that happens, when your analytics partners come back to you with another narrow question, and then you can just be like, the data's already there, they will be like, wow. Like, that is one of those things that really gets you a lot of kudos, because they're like, wow, like, I don't have to pull the data. Wow, I don't have to transform the data. I just have to do another query and I'm good to go. So that's why we spent, a lot of hours together working on data modeling, right? You listened to me talk for 12 hours, because getting the data model right is very important for building trust and really wowing your stakeholders. And this last bullet here is called follow the Airbnb MIDAS process. I will send you guys links for this as well. We're gonna go over the Airbnb MIDAS process in this presentation today. Also know that, like, my perspective on the Airbnb MIDAS process is that it's like most companies, they lean too little into quality. And I feel like the Airbnb MIDAS process almost goes too far the other way, where it's almost like too onerous. But we're gonna go over it, and even if you don't follow all of, I think it's like an 8-step process. It's a lot. Like, and so even if you don't follow all 8 steps, if you follow a couple of them, you will see a dramatic improvement in your data quality pipelines. So, or in the data quality of your pipelines. So don't think that I'm like saying you have to do everything that Airbnb does, because like most likely like you're at a company that might not have that many data engineers, and so they like it's not as possible. So yeah, let's dive into it. Oh yeah, 9. Wow, there's 9 steps. So let's I just want to go over each of these steps on like how Airbnb builds a very high quality pipeline and what it does with MIDAS pipelines. So MIDAS, I don't know if y'all know, he's like that's like a legend for like a golden touch kind of person, and King Midas, whatever he touched turned to gold. And so that's kind of the idea here. The MIDAS process is how to create golden data sets that are very valuable and they keep giving value. So the very first step of the MIDAS process at Airbnb is to make a spec. You make a spec, which is like, this is the pipeline I'm going to build, and this is how we're gonna build it. And then step 2, right, is that technical review I was talking about, and the stakeholder review. So spec review is you have to get a technical review from like a data architect, and then also a stakeholder review to make. I don't know if y'all know, he's like that's like a legend for like a golden touch kind of person, and King Midas, whatever he touched turned to gold. And so that's kind of the idea here. The MIDAS process is how to create golden data sets that are very valuable and they keep giving value. So the very first step of the MIDAS process at Airbnb is to make a spec. You make a spec, which is like, this is the pipeline I'm going to build, and this is how we're going to build it. And then step 2, right, is that technical review I was talking about, and the stakeholder review. So spec review is you have to get a technical review from like a data architect, and then also a stakeholder review to make sure it covers their needs. Then you do a build and backfill of your pipeline. So you actually go and write all the Spark code and the Airflow code, and then you actually create the backfill code for your pipeline. Keeping in mind here, when you backfill, you're not backfilling like all of history at first. You backfill like 1 month. So then the analyst who you're working with will then start working on step 4, which is the SQL validation, which is where they essentially go through all the data that you created, like that 1 month of data that you created, and just like dig super deep and try to make sure that there's not any weirdness or oddities in the data. And it's crazy because I built like 8 or 9 of these pipelines when I was at Airbnb, and like every time I like finished my backfill pipeline, I'm like, this is rock solid. I will never have to do it again. Like I know I got it perfect the first time. And like I like every single time, like without fail, there was always bugs. And that's why you only backfill a month, because if you backfill more than a month, then it's like, and then they find a bug and you have to backfill it all again. Like that's just painful. So then you do SQL validation. And keep in mind, SQL validation needs to happen by someone who isn't you, right? That needs to be usually an analytics partner, an analyst, or like an analytics engineer, someone who isn't you. Because if you build the pipeline, your ability to check the quality of the pipeline is impaired because of the fact that you built it. It's kind of like how, you know, people are very unwilling to admit that their children are ugly, even though we know for sure that some people have ugly children. Like, and you can just, but like if it's not your kid, like it's a lot easier to call the baby ugly. So it's a solid way to kind of go about things, right? So then after the SQL validation, then you have the Minerva validation. Minerva validation is where you're looking at the metrics. So Minerva is an open source metric repository container thing that Airbnb uses to hold all their business metrics, and they validate all the new Minerva metrics. And this is done by like, again, like the same person, usually the same person who does the validation, they do the Minerva review or the Minerva validation. Then you have 6, which is where the data architect comes back. So I would do these reviews as well, where after they did all of this stuff, I would then go over their code and their data. So in this case, for the data review, I would just make sure that there's not any weird like modeling problems, because a lot of times in the spec review, you're not going to catch everything as an architect. And so I just review in the data review a final thing of like, this column's weird, or like, why is this missing, or whatever. And so that's the data review. And then the code review is where I go through the Spark code. And a lot of times the Spark code, the big thing is looking to see if they have tests. So they need to write unit tests and integration tests for their Spark code. And this is something, if you're in the combined track, which I think about half of you are in the combined track, we're going to literally be going over how to do that tomorrow, on how to do unit tests and integration tests on your Spark code, and like end-to-end tests on your Spark code. That will be a nice, fun little project to work on tomorrow for you in the combined track. Then after that, you migrate the metrics. That's what the Minerva migration is. Then you have one more review by like a data scientist, like a staff data scientist. And he's like, what? Then after that, you migrate the metrics. That's what the Minerva migration is. Then you have one a nice, fun little project to work on tomorrow for you in the combined track. Then after that, you migrate the metrics. That's what the Minerva migration is. Then you have one more review review by like this is by like a data scientist, like a staff data scientist, and he's like, okay, these new metrics look good, and then you finally say we created the data set. And that's when you launch the PSA, and that's the ninth step. So I'm sure some of y'all are like, damn, that's like a lot of steps. Like, because a lot of times, like most companies, like when you're working, I know, like especially like when I worked at Facebook, how it worked was there was step 3 and step 4, and like that was it for the most part. Why all this upfront work though? Like, why are we doing this? Why are we writing all this documentation? Like, why can't we just write our data and give them the data and then they can go on their merry way? A couple reasons. And some of them are actually tricky for some engineers to understand sometimes. So if you get buy-in from a stakeholder before you build something, they're going to feel like they built it too because they gave you ideas, right? Like, it's kind of like how if you are like, yo, like, I want to get your opinion about this art piece, but it's before you build the art piece, and you're like, what should I put in this art piece? And then someone's like, you should put a dragon in that art piece. And then you put a dragon in the art piece, and then you show them, and then they're like, that's my dragon. That dragon's freaking sick, right? And then they love it more, right? Because they feel like it's theirs, like they were a part of the process, right? And that's a thing that analytics people really like, because, and it's also good too, because if you can make them feel like they're a part of the process, and then it's missing stuff, like they're gonna blame you less and blame themselves more, which is good for you, I think. I mean, it depends. Like, the blame game is also kind of toxic, but generally speaking, that can take a little bit of pressure off of you, because you're like, yo, like, you were, I looped you in for every step of this process. Like, why do we have to backfill again? And what it can do as well is it can highlight to management, like, where communication problems are happening, because sometimes as a data engineer, it's not even on you. Sometimes like analytics partners are just absolutely ridiculous in what they're requesting and like how they're requesting it. And so that's where, like, if you can loop them in throughout the whole process, and really, it's kind of like going on a bunch of dates with your analytics partners, because like, and you know, if you just go on one date with them and you're like, okay, we're building this pipeline, and then you don't even know if you're going to communicate with them well, and then like it feels like after you like it's like, and then it's like when you give them the pipeline, it feels like it's like buying your second date a car. It's like, and like, you know, I don't know, that a lot of people would say that that's probably a little bit excessive to buy, to give a girl a car on the second date. That's probably like a little bit too much, right? And so that's where you can kind of think about how building up these connections, having these conversations, what it does is it also surfaces like, hey, we're having communication problems. Hey, like, this isn't working out well, right? And you can catch these communication problems before people are so damn invested, where it's like you won't be like, oh, we had these communication problems, but then I still wrote 1,200 lines of SQL, and then I just freaking ate all the pain. And that is like, I've seen that happen. I've seen that happen many times in my career as a data engineer. And that's stuff like that is actually how a lot of data engineers get like meets most on their performance reviews, because they didn't communicate well enough, and then they didn't clarify things, and then they just jumped right into coding. And then it made it harder for them to undo things because they already had a lot of it built out. And so that is it's a beautiful thing. When this works, it feels very beautiful, and it feels like, wow, we are like in this process of solving all of these beautiful business problems, and like it can feel fun too. That's the part that I've found very interesting about this, is like, especially for me when I worked in pricing and availability at Airbnb, and I was doing these like stakeholder sessions of just like, oh, what do people want? Like, how do we want to change things? How do we want to implement things? And like actually really talking to stakeholders, like, whew, good stuff. That's that good shit, dude. Okay. And so anyways, obviously I said they feel like they have the skin in the game. They're a partial owner. It's like they have stock in your pipeline. So they want you to win as well, as opposed to like building something in a corner. And then obviously there's a thing in all caps here, like you want to do this upfront work because backfilling is painful. Like I feel like backfilling is like the B word for freaking data engineers. And so like don't worry about that too much. Like if you are doing all this upfront work, a lot of times, even if you do all this upfront work, you might still have to backfill twice. I mean, that's generally how it works for me. But like if you don't do this upfront work, you might end up backfilling like multiple times, like 3 or 4 times or something like that. And like that is getting a little bit excessive. That's also giving Jeff Bezos a lot of money. That's also just like, because data IO is one of the most expensive costs when generating data. And so like if you're backfilling a lot of history, like you're gonna have a hard time. So yeah, let's go to the next slide here. Okay. So obviously, like not every single pipeline is worthy of this 9-step process. Right? That should be clear. So there's going to be 2 big things here. I think one of them is, okay, are there any important business decisions made by this pipeline? And like important is obviously relative, but generally speaking, if it's not, and it's just more of like maybe exploratory, or maybe there might be obviously relative, but generally speaking, if it's not, and it's just more of like maybe exploratory, or maybe there might be a trend here, or like, because sometimes you do have that space to like kind of look at things in a more exploratory way in analytics. And those pipelines, a lot of those like exploratory, like prototype pipelines, they have value, but they don't have value in terms of like they need to stick around for years and years and years and give people value every day. And so those kind of pipelines, you probably don't need to do this 9-step process, and that would probably be a massive and ridiculous waste of time. But another big thing is like, if the data is going to change a lot, like if you are going through a lot of churn or process stuff, like then it might not be worth it to do it now, but like wait until that churn has like kind of happened. I know that was a big thing that was happening for me, like in unit economics, like payments was going through this big like refactor, and I was like, y'all need to like give me a MIDAS pipeline. And they were like, no, we're not going to give you a pipeline, because of the fact that like if we did, we'd have to just build it and then deprecate it in 3 months, because everything's going to be different soon. So like that's another thing to think about, is like some of this stuff, like this heavy process is really for multi-year master data that is going to keep giving value over and over and over again, and it won't be subject to very disruptive change. Or if it is subject to disruptive change, it happens on like a couple year basis, right? It's not going to happen soon. It might happen in a year or two. So that's a big thing to think about when you're going through these processes, because just because you're doing a heavy quality process doesn't mean you're delivering value. And sometimes not doing the heavy process will deliver more value. That's like a big thing to remember here, is that there is kind of a gradient here. Like it goes like you can go as far into quality as you want or as little into quality as you want, and like they have their pros and cons, right? It's not like always do the process or never do the process. There's a couple big things that make a good spec. One is the description of the pipeline. Like, why are we building this? Like, what is the purpose of this pipeline? You also have things like flow diagrams, like how things are, how things kind of position, and like how data goes from like the raw data to the fact and dimension data to the metrics. Then you have schema. Schema is going to be like your DDL statements and your create table statements, and then column comments to maybe talk about any oddities in any column comments. And you also want the quality checks, and like, because you want the quality guarantees in the pipeline, because that stuff that can be very good to add as well. Metric definitions, also important. Like, what metrics are you trying to even measure? And the last one is example queries, which is like, especially if you have more of that like struct and array format stuff from week 1 and 2. Having some example queries to show people can be very powerful, because then they might come and ask you questions of like, how do I query this? And then you have you already have a good example for them. So that's kind of the idea behind what makes a good spec. Okay, let's just kind of go over this, like what's in a good flow diagram. So here's a good example of like one that might be in a MIDAS spec when you're creating your data. So you see how we have our input data sets here. We have dim countries, dim users, and raw activity. And so these three come together, and then they create this fact table called fact activity. And that is going to be our this is like the master data. Generally speaking, I would say that this orange table here would be what's called the master data. That is going to be what most people query. And then you have you can also create like an aggregate table, which you can think of as just grouping this table and moving it down. And then you can aggregate the aggregate table and create the fine grain metrics, and this will give you like some ratio metrics. These are per user. Obviously you can have other metrics that are like totals and stuff like that as well, but generally speaking, like these diagrams, I like to use Lucid Chart for this. That's what I use this for. You can get like a free trial for Lucid Chart, and you can build this for free. Google Drawing's okay, but I don't know. I feel like every time I use Google Drawing, I always feel like I'm like a kindergartner who's like writing my freaking flow diagrams with crayons, and like I don't know, it doesn't feel good to me. It doesn't feel good to me. So I'm more of a Lucid Chart kind of guy. But that's, you know, at Lucid Chart, you should sponsor me. Okay, let's go to the next slide. We talked about schema. So your table names should look good. Generally speaking, your table name should have either fact, dim, SCD, or ag in the name. To illustrate what type of table it is. So it's either a fact table, a daily dimension table, an SCD dimension table, or an aggregate table. And like pretty much every single table at Airbnb, Freaking had one of these in the name. Like that was kind of like a requirement. And it made it so it was like a lot more obvious, like what kind of table this is going to be. And then if you have people who just have even a basic understanding of data modeling, they can understand like, okay, this table's for events. This table is for dimensions, right? And you can get all sorts, you like just from that in the name, you get a lot of information. So obviously for your schemas, you also are going to need a lot of comments for your columns. Like make sure that every column has a comment. And these comments should follow the naming convention that your company chooses. And if that doesn't exist, if you're at a company that doesn't have naming conventions, then that's a great place to freaking get a lot of impact. And that's something that you should be yelling at people about, where it's like, why do we not have consistent naming conventions? Why are we doing things this way? Like, obviously, if everyone's going to do their thing their own way, like, people are going to have a harder time understanding this data. And so, like, you just got to be very clear with people. And this can be a massive way to get a lot of impact. Like and there's a lot of companies that aren't doing this, because I mean, a lot of companies aren't big tech and they're not like so far advanced in their data practices that they even have this yet. So that can be another great place to go. But the key thing here is follow the naming conventions at your company or build them if they don't exist. Comment every column. Every table name should have fact, dim, SCD, or ag in the name. Those four, if you do those four for your schemas, you're going to be very far ahead of a lot of different people. So that's a good way to build good tables that have good names and good columns. Quality checks. We're almost here, and then we're going to take a break here in like 5-10 minutes. Been talking a lot. So quality checks come in three flavors. You have the basic checks. Basic checks are really easy. Basic checks, generally speaking, like every pipeline should have these basic checks all the time, because if they didn't have these basic checks, like what are we doing? They're so cheap. They're like free essentially. So like, and they also help a lot. Oh, I forgot to add one. There's one more basic check, which is like, is there data? Like there's actually data, right? There's the not empty check. And then you have not null for any column that's not supposed to be null. Like it's never null, no duplicates. Make sure that's the case. And then enums, right? We've talked a lot about enums, and make sure all the enums are a valid value, because in the data lake environment, like it's different from Postgres. Postgres is going to enforce it for you, and you don't have to worry about enum values. But if you're in the data lake environment, like in Spark or in Presto, like it's a lot more flexible. So you need to test these values yourself in your data quality checks. Then you have like intermediate checks. Most of this is like row over or week over week row counts and everything like that. So in this case, like when you look at like week over week row counts, you want to do week over week and not day over day, because of the fact that like Saturday versus Friday is going to be weird, because a lot of times companies and things have different behaviors on Saturday than they do on Friday. But if you compare Saturday to last Saturday, that's going to be a better consistent trend. There still could be other seasonality things that happen on a longer term cadence, like, for example, holidays, right? Where like Christmas, these intermediate checks, like they fail on Christmas all the time. Like it's annoying how often they fail on Christmas because of like the seasonality. But companies are getting more mature, and they're actually getting more like machine learning and stuff like that involved as well, so that then you can do seasonality adjusted row counts, so that then you can look at both week over week, but you can also look at it in context with like last year or the year before, so that you can get like a longer term seasonality context, so that like your data quality checks don't false positive more than they should. And that's how you get into those advanced checks, where you like bring in the heavy guns, you bring in the machine learning, you bring in all that stuff. And that can oftentimes make your quality checks higher signal and less noise. And that can be very powerful, but like bringing these in can also be kind of expensive depending on the company that you're working for. So as your data infrastructure improves, generally speaking, these advanced checks become very easy to add. I noticed that like at Airbnb, it was like seasonality adjusted row count was like, it was like a YAML configuration, one line of code, done. So how do you pick quality checks? So dimension and fact tables generally require different quality checks. We'll go over that real quick here. So dimension tables, generally speaking, they either grow every day or they're flat. Especially if you're doing like cumulative table design, then like they should be growing or flat every day. So a very common check for dimension tables is table is growing, which is like, is there more rows today than yesterday? And like it should almost always be like an up and to the right trend. That's like but like at the same time, you don't want them to grow too sharply, which is similar to that threads example that Stephanie just brought up, is like, because like if you have like week over week, say there was like 100% more users, and it's like Facebook's like, we didn't get 2 billion signups this week. Like, no way, right? And so there's going to be a percent that is reasonable for your users depending on like the volatility of your data set. And then you also like, you want to make sure your complex relationships are also checked. So in that case, like for example, on Facebook, there is like, say you're working in the friending environment. One of the hard limits in friending is you can only have 5,000 friends on Facebook. And so like, you want to check that. Make sure that there's no one more than 5,000 friends. Like, make sure that that's like enforced in the data, right? And other things too, like say I have progressive car insurance, and it's like, if I have an active policy, there should be a car in my policy as well, not just me, right? Because Progressive doesn't do like health insurance, right? They only do like car insurance. So you can think of like all the different like connections of your entities, and sometimes they have to exist. And like if they have to exist, that should be a check in your data pipeline. So that's the dimensional data. Then you have fact quality checks. So facts usually have like the seasonality problem. That's where like if you have row counts, you don't want to do day over day because the whole Saturday, Friday problem. Always do week over week. Again, this can have a problem where it's affected by holidays. Facts can grow and shrink based on user behavior. So in that case, the table is growing check from the previous slide is not a good check. Facts are more prone to duplicates because duplicates are a lot more likely to happen in logs than they are in production databases. So the duplicate check is very important in fact data. More prone to nulls and other row level quality issues, obviously, that stuff. Like, because it's logs, and logs a lot of the time aren't critical for the app to run. And so that can be where software engineers can get more sloppy when they're working on logs than when they're working on like production database snapshots. So that's also true. And then obviously they can have a foreign key. It's like you can have references like, it's like I received this notification from Facebook. You got to make sure that that user ID is real, and and this is cool as well. You can also do other enforcement. Like, what if you have deactivated users, right? So it's like, we want to make sure that there's no deactivated users on Facebook who are receiving notifications, because that is also like a bug. It's a different bug, right? It's not really a data quality bug, but it can catch infrastructure bugs that are happening like in other places in the app. So you can also catch things like that, where these data quality things actually caught some like cybersecurity problems at Facebook a couple times, and they were the first place to alert that like, hey, there's an issue here. Some people are getting hacked. Something is happening here. And so know that like these data quality things aren't just to build trust in you, but they can also help the business in kind of ways that you wouldn't expect, especially if you do a good job here. Okay. Last thing I want to talk about is like in the dupes. When I was talking about dupes in for fact data. Don't use count distinct. Like when you're in Presto, just don't use it. Like it's terrible. Like it's so terrible. And like a lot of times, especially if you have high volume fact data, Presto will just die because count distinct in Presto is terrible. If you use a prox count distinct, that's going to be better. And that's going to capture 99.9% of the data. There could still be a chance that there's like one duplicate, like in some like far away land, but this is going to capture 99.9% of the time, and it will make your pipeline run faster. So if you're doing your checks in Presto, use a prox count distinct and not count distinct. It's just like a random little tip.
Congrats on getting to the end of the spec building lecture. There's a lot of steps in the MIDAS process, right? If you're taking this class for credit, make sure to switch over to the other tabs so that you can get the time tracking that you need for the lab. I'm excited for you to check this out.
So